You are in a field. You see movement in the tall grass. It looks like a duck. It walks like a duck. It quacks like a duck. One explanation, it's a duck. Another, it is a goose that has put on a duck costume, infiltrated the flock, and is pretending to be a duck. Which one should you prefer? According to a famous principle in science, you should go with the duck. This is Occam's razor. The principle that when faced with competing explanations, the one with the fewest assumptions is usually the best place to start. It is one of the most famous rules of thumb in science. But almost everyone gets it wrong. Welcome to Grossdenken, everyone. Today, we are going to find out what Occam's razor actually is, where it came from, how scientists use it, and why the simplest explanation is usually the best is not quite right. Please support this science channel grow by just subscribing. That would mean a great help. Occam's razor is named after William of Ockham, a 14th century English Franciscan friar, theologian and logician. He lived from about 1287 to 1347. William was a radical thinker. He argued that plurality ought never be posited without necessity, which roughly means don't assume more than you need to. But here is the catch. The most famous Latin version, "Entities must not be multiplied beyond necessity," was not written by Occam. It was written by a later philosopher, John Punch, in 1639. Occam never said those exact words. And the term Occam's razor itself did not appear until 1852. In his own works, he wrote, "Plurality ought never be posited without necessity." That is the real phrase. So what does the razor actually mean? The most useful scientific formulation is this. When you have two competing theories that make the same predictions, the simpler one is better. The one with fewer assumptions. Isaac Newton used it. He wrote, "We are to admit no more causes of natural things than such as are both true and sufficient to explain their appearances." Einstein echoed it. Everything should be made as simple as possible, but not simpler. A crucially important qualification. Notice the condition, same predictions. Occam's razor only helps you choose between two theories that explain the evidence equally well. It does not tell you to ignore evidence or choose a simple explanation that fails to explain the data. It is a heuristic, a rule of thumb, not a proof of truth. Computer scientist Pedro Domingos pointed out that Occam's razor is often interpreted in two very different ways. The first razor. If two models have the same predictive power, simpler is better because simplicity is desirable in itself. This is essentially uncontroversial. The second razor. If two models have the same training set error, the simpler one is likely to be more accurate on new data. This version, Domingos argues, is actually false. In machine learning, complex models like deep neural networks often outperform simple ones. The universe is not obligated to be simple. Sometimes the simplest explanation is wrong. Complex problems often demand complex answers. Occam's razor is a guide, not a law. A classic example. In 1976, the Viking 1 spacecraft photographed a region of Mars that looked like a human face. One explanation, an ancient Martian civilization built a monument. Another, shadows and rock formations created an optical illusion. Occam's razor said, go with the simpler explanation. When the Mars Global Surveyor took better pictures in 1998, the face disappeared. It was just a hill. Another classic. Two students sitting next to each other answer a paragraph-long question identically and incorrectly. Did they both independently invent the same wrong answer, or did one copy from the other? Occam's razor says, they cheated. The explanation requires far fewer assumptions. But Occam's razor can be misused. When Ernst Mach applied it to molecules, he argued they were metaphysical because they were too small to see directly. Einstein's paper on Brownian motion confirmed their existence and dealt a blow to the razor-first approach. In medicine, Occam's razor is contrasted with Hickham's dictum, which states that patients can have more than one disease, rather than a single simple cause. Sometimes complexity is real. Modern statistics has a more sophisticated version, Bayesian Occam's razor. It mathematically penalizes complexity, but only when the added complexity is not justified by the data. It is not about simplicity equals to truth. It is about unjustified assumptions equals weakness. Why does the razor work? Because for any set of evidence, there is an infinite number of possible explanations. You can always add ad hoc hypotheses. Occam's razor cuts through the noise. It says, start with the explanation that requires the fewest leaps of faith. It does not guarantee you are right. It does not say complex theories are wrong. It says, unnecessary assumptions are a weakness. So what is Occam's razor? It is the principle that when multiple explanations fit the evidence, the one with the fewest assumptions is the best place to start. It is named after a 14th century friar, used by Newton and Einstein, and built into the foundations of modern science. But it is not a proof of truth. It is a tool for thinking, a way to shave away nonsense without shaving away reality. Thanks for watching, and hit subscribe for more deep dives into the mysteries universe.